Alright, so right now we're going to be practicing questions, important questions from 5 chapters of chemistry. So the first question that we're going to tackle right now is this one. Just one second. Yeah. So the question is, how many moles of Al2O3 will be formed when a mixture of 5.4 gram of aluminium and 3.2 gram of oxygen is heated? So the first thing you want to do is write the reaction, which is plus O2 gives Al2O3. Now, if you want to balance the reaction, you could do this. Just one second. So you're gonna balance the reaction. So this is what you're going to get. So this is a balanced equation of formation of Al2O3 aluminum oxide. Now they're basically asking how many moles are formed when so much and so much gram of oxygen is heated. Now the first thing when you see these kind of questions you have to do is find the limiting reagent. So to find that, the first step would be to find number of moles. So this is what they've given. And aluminium is 27. Yeah. And for oxygen, they've given 3.2. And the bottom is 32. 27 twos are 5.4, so it'll be 0.2. And here it's going to be 0.1. And now what you do is with this moles, you're going to divide it with the stoichiometric coefficient, which is this. It's going to be zero point 0.2 by 2 and zero point 0.2 by 3. So definitely this one is a limiting reagent. Therefore, oxygen is limiting. And what is you're going to do is now it's time to find the number of moles of Al2O3. So already what you can see here is 3. Okay, you need to find the moles, right? Okay. 3.2 moles are giving 1 mole of Al2O3. Then 3.2. Let's just take this like this. So what I suppose, yeah. So basically this is the answer, which is 1 by 15. So this is the number of moles for Al2O3. Alright, so now let's go to the next question, which is 2 liters of N2 and 2 liters of H2 on complete reaction would give some how much liter of NH3. Again, we've got a reaction to be written here. So this is a reaction and they're asking how many liters of NH3 will be formed. Okay, so in this case, again, you need to find which is the limiting reagent. So for that, I think in my case, I'm going to use this particular method. For example, they've told 2 liters of N2. Now 2 divided by 22.4 would give the moles of this. And here also 2 liters of H2. So 2 divided by 24 will give you the moles of that. Now that you need to divide it with the number of moles or the stoichiometric coefficient. So this will be into 1 by 1. This will be into 1 by 3. Now which one is the smallest one? Definitely this. So H2 is limiting. And what happens next is you need to find the number of liters of NH3 already. So 3 moles of this gives 2 moles of NH3. Then 2 liters of N2 would give how much liter of NH3. Let's take that as x liter of NH3. So we get 4 by 3, and 4 by 3 is 1.33. So that is the answer. So let's just go to the next question. Yeah. So next question is 2 gram of base X requires 100 ml of 0.4 normal acid for complete neutralization. The equivalent weight of the base is what they're asking us. Alright, so what is equivalent weight? It is okay. Let me quickly check what equivalent weight actually is. So equivalent weight is formula weight of solute by valency. Now they've just given the base X and acid, so we'll not be able to find the N factor, but equivalent weight is most likely would be the molecular weight. Now we could try N1V1 is equal to N2V2 since neutralization is supposed to take place. So for normality, it will most likely be so it'll get cancelled. Here you're going to have they've given 0.4 normal. Okay, let's try this. So this is what is in my mind right now. And polar mass, let's see. But something is switching here. Okay, I'm getting 50 as the answer. Let's check the answer key. 29 is second option. First option, okay, first option is right. It's exactly what we're going to do. So there's one thing that I want to do when I solve questions is basically if I find any new kind of method or new kind of formula, I think I really want to add that in my notes. Yeah, not be a problem later on. So this was neutralization. Alright, so let's now go to the next question, which is normality. Okay, no, that one. A metal oxide MO has 40% of oxygen, the equivalent weight of the metal. So we basically need to know the formula mass of the metal, right? This is what we're supposed to find. Now, since it is MO, it could be a monobasic, right? Sorry, not monobasic, but the metal could be monovalent. One sec. Yeah, so it could most likely be monovalent. Now, since when I see the 40% oxygen, we could talk even about percentage composition. So it can be like 40% of quote oxygen is 16 plus the rest will be 60% of molar mass of M divided by 100 would give you 16 plus x. I could take this also as x. No, so 64. So this is the method I'm following, which I'm quite not sure if it's right, but let's move on with the method and try, because I'm getting a negative value which is most likely not supposed to happen. Something like this. Okay, it's literally there as one of the options, but definitely not sure if that's right. So let's quickly check that out. 31st question is 1. Okay, so it's not right. So there is something else in the question. Alright. So there is something that we need to remember. If it's MO, it can't be monovalent, but it has to be divalent, right? Because oxygen has 2 minus. So if the metal has 2 plus, that's when we get an oxide of MO. So for alright, wait. So it will most likely be a bivalent metal. That's exactly why I think it might not be 24 and divided by 2, which is 12, because 12 is the answer. Let me quickly check it out, because I'm not even sure if the method I've used is right. Because another important thing to do is always check if the method you're solving the question is right, because you might even go the wrong method and multiple get the right answer. One. They've taken it as 40 gram and 100 gram, and in the method they've used here is W1E1 is equal to W2E2. Because of considering the whole mass of the metal to be 100, then oxygen to have 40 gram and the metal to have 60 gram. So then we might get, so as, alright. So how exactly they've done here is equivalent weight is nothing but mass by n factors, right? So the n factor of the metal would most likely be the mass divided by 2. So that's exactly how you get the molar mass of the metal, which is 20 divided by 2. Because they would have asked mass of, like molar mass, we could have written it as 24, but they've asked equivalent weight, which is 24 divided by 2, 12. So that's exactly how we get it. Alright, next go to the next question, which is, before us it's question 5. So 10 ml of N by 2 HCl, 30 ml of N by, okay, let me write that down, of N by 2 HCl, 30 ml of N by 10 HNO3, and 75 ml of N by 5 H2SO4. So these are mixed together. The normality of the resulting solution is what they're asking. Now, normality, according to what we've read about, is N1 V1 plus N2 V2 plus N3 V3 divided by V1 plus V2 plus V3. Now, since it's normality, we might have to take into account about the n factor of H2SO4, because HCl and HNO3 could be 1, but H2SO4 is definitely 2. So we have to multiply or divide by that. Most likely it's multiplying it with the n factor. Yeah, so it's going to be like, yeah, so that's exactly how we're going to do. And n1 is 1 by 2 into 10. Okay, so there was this mistake that I used to do usually, which is taking the n by 2 as n by 2 and thinking what is normality. But that's completely wrong, because n by 2 is nothing but 1 by 2 normal. So that's something most of us could get confused on. So 1 by 2 into 10 plus 30 into 1 by 10 plus 75 into 1 by 5 divided by, okay, this one into 2, okay, and this will divide by the total volume. So how much is the volume? 75 plus 30 plus 10, which is 115. So we have 5 millimoles plus 3 millimoles and 15 to the 30 by 115. And how much are we gonna get here? We're gonna get 38. Not sure if the answer will be right, but let's check it out. Okay, probably not, because the answer is weird. Because the answer was in 0.2, but here I'm getting around 0.3, which I think is not the right one. Or the 75 ml. Are we supposed to divide it into 2? It's gonna be 15, 130. No, I think so. Oh, we could. Yeah, because It could be a reason, but I'm still not sure, so let me check the answer. According to what they've done here is they've gotten, okay, they've divided the normality with n factor. That was the only wrong thing that we've done. So because so let's since it's something new and it's a mistake that we've done, I think we can add that to our picture like this so you get so it most likely rounds off to give you the answer point two. But other than that, I'm gonna correct. So it's a small silly mistake kind of that we've done. So I think we can now remember that to find it, it's only going to be in the terms of molarity. So if even if you have normality, you need to convert into molarity by dividing it with the n factor of it. Okay, so now let's go to the next question. This question number 6. A solution of NaOH is basically 4 gram per liter. What volume of HCl gas at STP will neutralize? 50 ml of the alkali solution. Okay, so this is basically 50 ml, I suppose, because that's the alkali right there. Now, to find the neutralization, we could use this formula. So M1V1 is equal to M2V2, and you need to know the molarity. You already know the volume of it. Now they've given it as 4 gram per liter. So if it's 4 gram per liter, to get to know the molarity, we could do 4 gram per liter divided by 40, which gives you zero point 0.1 molar. And we need to find the volume of HCl gas. Further, we need to know the molarity. Okay, HCl gas is at STP. So if it's at STP, it's going to be 1 molar, right? It's gonna be like 1 mole would be, but it's not right. Because we've asked HCl is at STP. Because this gas at STP will neutralize 50 ml of alkyl solution. And we need to find what volume of gas, what volume it is, that one. And NaOH is so much. So I think I'm gonna just search it because it's kind of driving me. Okay, so calculate the molarity of NaOH. So they've done it the same. They've got 0.1 molar and moles of NaOH is NaO molarity of NaOH into volume, and they've written the reaction. Okay, so if the moles of Na, okay, so for NaOH, if it is 0.005 molar, then even for HCl, it's supposed to be the same molar. Now, what they've asked is how much is the volume required to neutralize it. So, and moreover at standard temperature and pressure, the volume is 22400 ml. They've basically multiplied that with the STP volume to get the answer. I still don't get how. Okay, I've understood this part. It's most likely gonna be. And this is the same even for HCl. Okay, so probably they've done it like this. 22.4 liters for 1 mole. Then for 0.005 mole, how much is the volume? And they require it in ml, so we're going to do this. So why am I getting 11.2? Let's check it again. It will be 0.05, right? Yeah. Then this will be 0.005. Yeah. And that's exactly what I was looking. 0.5. Oh, alright. It will be 0.5. And we'll get it as 112 liter. Okay, so that is up with the question. Only thing we need to remember is the number of moles of acid should be equal to the number of moles of base, and hence for them to neutralize. And then since they've asked it in STP, remember that initially it will have 22400 ml. because that is a like volume in STP condition, right? Okay, now that we're done with that, let's go to the next question, which question number 7. So concentration, okay, this is a pretty important question, and I really think we should take time to understand it properly. So what they've given is, so let me do it in a diagram format so that it's easier to understand. So concentrated H2SO4 this is, which is 98% by mass and has a density of 1.84 gram per centimeter cube. So now they're asking what volume of concentration of the concentrated acid is required to make, so how much volume are you going to take from this so that you can make another H2SO4 solution, which is 5 liter and 0.5 molar. Okay, now let's take a simple assumption based on the knowledge we already have, is finding the mass of H2SO4 here. Now you know H2SO4 98, right? So 98 mass into 1000, sorry, it's all in liters. Let's just take like this is equal to 0.5. The mass though will be like this. Multiply 98 into 25. So it is 2450. And since there is a point, it's going to be 245 gram. So much is the gram you need, but they're asking volume. Alright, so let's just keep this aside. Now let's check over this side. So it's basically 98 gram of H2SO4 in 100 gram of solution. And they've given density. So how can you assume density as? It's basically like one, so centimeter cube is also same as ml, right? By the way. So 1.84 gram of solution is in how much? 1840 ml of solution. Okay. So this is the knowledge that we have so far. Now we need to somehow get 245, right? So how much do you require from this side to get 245 gram? So how much is the volume, right? So let's say we are finding the molarity. So okay, wait, 98 gram of H2SO4 is in 100 gram of solution. Then 1.84 gram of solution. Yeah. But another thing that I can observe here is we could find molarity, which is 10 into weight by weight percentage into density divided by molar mass. So you're gonna get something like this. But why is it 18.4? It's most likely not gonna be that because molarity won't be that huge, by the way. There is something in it. Okay, moreover, that is gram per centimeter cube. So it means like this. So if this is the molarity, we need to find. Okay, so let's quickly check this out because I think this is as far as we could understand the question. I don't get, but they've used dilution formula, which is M1V1. Okay, okay. Molarity also they've gotten the same. They've literally used dilution formula and made it really simple. Okay, let me quickly. Yeah, there's another website where they've given something similar to what we've done because they've calculated the mass of H2SO4 needed. And how many moles of H2SO4 required. Alright, so just I don't think I have what I'm looking for, but it's fine. Let's go with it. Let's continue with the solving of the questions. So, what exactly they've done in here is here they've found the mass of H2SO required. So, what about the moles of H2SO required? They've done 0.5 and 5, 0.5 moles of H2SO required. And what about anything else? We need volume is already 5 liters here. And basically they've used this dilution rule. And dilution rule, there is this formula similar to the neutralization cutting. So M1 V1 is equal to M2 V2. And from here you basically get this to be around 18.4. And here we need to find V, right? And molar we already 0.5 is something we already have. And we have 5 liters. So I'm assuming this is how they've done it. So this is how much, and into 10 power 3 could give you it in ml, which is 136 ml or centimeter cube. So this is exactly what they've done. Alright, so always remember that if there is any question like this, it's usually related to dilution, so that we could solve stuff like that later on too. Okay, moving on to the next question. I think it's going to be the eighth one. So 1 gram of mixture of calcium carbonate and MaCl reacts completely with HCl. The percentage of CaCO3 in the mixture is yet another question. So both of these are 1 gram. If this is 100 ml of 1 by 10 normal. So shall we find the moles? Okay, first we need to find the molarity of the resulting mixture. So how much is the volume? So let's do that. One by 100. One would be So you might get 10 millimoles of HCl, and that should be equal to, okay, I think we could get it. So if it's 10 millimoles divided by 1000, we have 0.01 moles should be equal to 1 by 100 into V plus 1 by, how should we get it here? 58.5 into V minus, sorry, 100 minus, no, let's do it like this. Take it this way. No, it's going to be harder. Both of these are together 1 gram. But what if we could do 0.5 divided by 100 plus 0.5 divided by 3.5? 0.0135. This is, so would it be something like this? 0.74 liters. What am I gonna do with this, by the way? It fetches me nothing. Alright, this is a pretty weird question, which I'm gonna check again. So we got the 0.01 moles. Okay, the N factor of CaCO3 is 2. I've forgotten about that. So basically, they're done with the same method as we've seen earlier, which is once they get the moles, they're finding it for only CaCO3. Now, I doubt this. Then what about NaCl? And moreover, for CaCO3, remember that the n factor is 2. Therefore, most likely, even if we get it as 100, we are supposed to divide it by 2. And then they get the mass of CaCO3 and then they find the percentage composition. There is still a doubt, so I think I'm gonna go with the next question and then let's come back to this one. So next question will be the question 9. So we have a metal chloride which is of mass 74.5 gram that contains 35.5 gram of chlorine, and they're asking equivalent weight of metal. So we know that equivalent weight is molar mass by n factor, right? So they've given it as a chloride, metal chloride. We have no idea about what's the valency of these and what could be the n factor, but let's just, so if we take this, we can easily get it as 39 gram, right? Well, there is an option with 39, but I don't think that could be the one. This is mere subtraction, and I don't think they'll give anything where there is mere subtraction. So if there is this 35.5 gram of chlorine and so let's first check the answer to this one. It's section B 36 to 39, that's it. Mere subtraction and nothing else is confused. Okay, so let's just check. This is basically the answer, but we definitely have to know what's the right method. Actually, if it was a different metal, they have kind of used a different formula for this. Like we are supposed to use W1 by E1 is equal to W2 by E2. But since it's like monovalent and n factor is 1, it's gonna remain the same. So that's exactly why this is the answer. Okay, moving on to the 10th question. So the volume of 1 liter water upon vaporization at STP. So it's basically gonna be like H2O in liquid state is becoming H2O at gaseous state. And initially it's 1 liter. So they're asking how much would be the volume when there is vaporization at STP. I thought it was gonna be 1 liter because like 22.4 liters. Sure, might not be the same. So let's quickly check the answer. It's not the same. Okay, they've taken an important relation, which is density of water is 1 kg per liter and molar mass of water is 18 grams per mole. Okay, now molarity also you could find like 1000 gram by 18 gram, which would be 55.5 molar. No, mole. No. So 1 mole at standard STP would take 22.4 liter. Then 55 point mole would take how much? Is what you would find out to get an answer of this. But alright, so let's move on to the next question. So we have one more. Okay, so this one is basically 1 mole of 22.4 and 55.5 mole would give how much? But okay, let's move on to the next question, which is gram equivalent volume. It's a live question. Of O2 at STP. Okay, so how exactly, now what exactly is gram equivalent according to what we've learned is, and moreover they told it is at STP. So since volume, let's remember we have to do something with this. And so the n factor of O2 is something that we need to know. Is usually what we take it as is 2, but in this case it is not that. Alright, so the formula for gram equivalent itself is weight of solute by equivalent weight of solute. And equivalent weight of solute is formula weight gram factor. Yeah, there was something just about it. Let's check the answer once. Let's I'm getting a bit confused about 13 minus 2, which is 4.6. Alright, so this again is. Alright, so I think I'm gonna end it here because this one requires some knowledge to be done with before I end it in ChatGPT. Let's do that. Okay. So what it has told is work for 1 mole of any gas at STP is 22.4, and for O2 1 mole corresponds to 4 equivalents. That is, it accepts 4 electrons to form 2H2O. Okay, but I still don't get it. Alright, so this is the answer. You got it, and we're going. Bye bye.